prevention. In context of economic affairs, prevention of this microbe is far more important than the prevention of other microbes. There are several reasons. Number one, Pseudomonas aeruginosa is opportunistic bacteria, and when there is a lack of infection control measures, it takes opportunity. It takes opportunity and develops infections. And when it develops infection, the reason number two comes forward, for which I can say preventive measures are far more important in the case of Pseudomonas aeruginosa. Reason number two is when the Pseudomonas aeruginosa has caused infection, then to treat the infections are really a hard task, because Pseudomonas aeruginosa is resistant to a wide variety of antimicrobial agents. Even very good antibiotics are not working in the case of Pseudomonas aeruginosa. Okay, so what we have to do, we have to use anti-pseudomonal antibiotics, which are really very expensive, and that's why treatment is expensive while prevention and infection control measures are cheap and quite effective. So to decrease the economic burden on the hospital due to Pseudomonas aeruginosa infection control measures are far more important in the case of Pseudomonas aeruginosa. Let's move on to the recommendations for the good infection control measures. Number one, observe proper hand hygiene. Nosocomial spread of bacteria, including the Pseudomonas aeruginosa, is frequently by hands, and the bacterial contents of hand are higher in hands which wears rings. Bacterial contents of hands are higher with hands with long fingernails, with artificial nails, and with other accessories. So, proper education of the hospital-related personnel on hand hygiene is vital for the successful control of Pseudomonas aeruginosa. Another related point to the hand hygiene is, do not use bar soap. Use hand soap from a non-reusable container. Okay, the second recommendation, good housekeeping. Good housekeeping limits the chances of transmission of Pseudomonas aeruginosa. Recommendation number 3, do not bring flour or raw vegetable in burn unit or in a unit where immunocompromised patients are present. Pseudomonas aeruginosa is present in ample quantity on raw vegetable and on flowers. And the immunocompromised patient, the burn patients, must not be exposed to the Pseudomonas aeruginosa. So prevent these things from sick patients. So express your feelings and show your sympathy with even more compassionate words, and avoid flowers in burn unit and in other units where the immunocompromised sick patients are present. Recommendation number 4, use sterile water for rinsing, for washing medical related equipment, for medical devices. Do not use tap water because the tap water is full of Pseudomonas aeruginosa. Recommendation number 5, limit broad spectrum antibiotics. Why? Broad spectrum antibiotics disturb the natural flora of the skin, the natural flora of the patient, and gives the Pseudomonas aeruginosa an opportunity to cause infection. That's why limit the use of Pseudomonas broad spectrum antibiotic. Lastly, some precautions about cystic fibrosis in the case of cystic fibrosis patient. Place all patients with cystic fibrosis in a private room. And these private rooms should not share common facilities, should not share bathrooms or showers. And please avoid direct contact with cystic fibrosis patient in a hospital, because some strains are really very highly resistant in the case of cystic fibrosis. Before we end up this session, let's look at some new ideas, some advancement for the infection control measures. You can see this picture, okay, in which there is a dragonfly and there are some surface structures. Okay, there is a study, and this study proclaims that the black silicon mechanically kills Pseudomonas aeruginosa. Black silicon has been made in such a way that it has nanoprotrusions on its surface, and these nanoprotrusions, which are shown in a subset, mechanically kills microbe, including Pseudomonas. So there is a hope. There is a chance that these surfaces and the surfaces made with silicon, black silicon, can mechanically kill the microbe. Okay, what's the dragonfly is doing here? Actually, the surface structure of the wings of dragonfly have spike-like nanoprotrusions, which mechanically kills microbes. Similarly, the spike-like nanostructures of the black silicon may kill the microbes mechanically. So, this is another example where the scientists are inspired from the architecture of nature, and that's all about the prevention of this bacteria. And now, the final and the last section of this whole discussion, which is about treatment. Treatment of Pseudomonas aeruginosa is not simple. Okay, it's fairly complicated. But we are not going to have a robust discussion to deal with this complexity. We shall make some general ideas about the treatment options. I said treatment option is complex. It is complex for several reasons. One reason is Pseudomonas aeruginosa is resistant to many antimicrobial agents, and this resistance is inherent because Pseudomonas aeruginosa possess such cell wall which have porins with very small diameters, and these porins do not allow antimicrobial agents to get into periplasmic space and do its function. Reason number 2. There are strains of Pseudomonas aeruginosa which are even resistant to anti-pseudomonal antibiotics. So for these reasons, the treatment of Pseudomonas aeruginosa is complex. It's not fairly simple. So how to deal with this situation? We can deal with this situation by having all treatments guided by antimicrobial susceptibility tests. And please have frequent sensitivity tests, and these sensitivity tests are necessary to monitor the treatment because resistance is fairly common in the case of Pseudomonas aeruginosa. And we can deal with the complexity of treatment by having susceptibility test, by having monitoring of the treatment. Okay, now I am going to put the antimicrobial agents which are active against Pseudomonas aeruginosa, and then we shall make brief discussion about each of them. Number 1 antimicrobial agent which is effective against Pseudomonas is extended spectrum penicillin. Number 2 is carbapenem. Number 3 is aminoglycosides, and number 4 cephalosporin. Number 5 fluoroquinolones, and number 6 monobacter. Number 7 polymyxin B. And let's have a brief discussion about the extended spectrum penicillin. Extended spectrum penicillin includes ticarcillin, piperacillin. These two agents are extended spectrum penicillin. These are extended spectrum penicillin and covers the Pseudomonas aeruginosa as well, but they are not used alone. Reason is this, that with single agent the success rate of therapy is low and the emergence rate of resistance is quite high. So these drugs are combined with other drugs, and by combining these drugs with other drugs, we can have synergistic effect, and we can cope with the problem of resistance. Okay, so extended spectrum penicillin are usually combined with aminoglycosides, usually with tobramycin. Okay, now come on to the second class of drug, which are carbapenem. It includes imipenem and meropenem. Carbapenem is a new class of beta-lactam antibiotics, and imipenem is an important carbapenem. It has very broad antimicrobial activity. Almost all bacteria which are difficult to treat can be managed with imipenem. To remember this fact of imipenem, you can imagine imipenem as IM pen. And this pen cross out all the difficult bacteria. Okay, it crosses out all the difficult bacteria, means that it kills all the difficult bacteria, all the bacteria which cannot be handled with other antimicrobial agent can be dealt with imipenem. Okay, why this drug is so much successful? Why this pen is so successful? There are reasons. Reason number 1 is it is stable beta-lactam antibiotics. It is stable to beta-lactamase. Reason number 2 is its molecular structure is so small that it can cross through the porins of the cell wall of Pseudomonas aeruginosa and can get into the periplasmic space, where it interacts with the transpeptidase, and by having this interaction it stops the cell wall production, and by stopping the cell wall production it actually kills the bacteria. So it's bactericidal agent. Let's come on to the third category, which is aminoglycosides. newer aminoglycosides, which include the tobramycin, gentamicin, amikacin. These are quite effective against Pseudomonas aeruginosa. They are combined with carbapenem or extended spectrum penicillin. And when they are combined together, they are used to treat very serious life-threatening infections of Pseudomonas aeruginosa. Example is, in neutropenic patient, the treatment option may be tobramycin combined with piperacillin. Okay, this combination may be the treatment option. Next thing is cephalosporin. Cephalosporin of third and fourth generation are active against Pseudomonas aeruginosa. The agents in third generation which are active against the Pseudomonas aeruginosa include cefoperazone and ceftazidime. In fourth generation we have cefepime for the Pseudomonas aeruginosa. Like other antimicrobial agents, cephalosporin are combined with other antimicrobial agents to deal with the issue of emergence of resistance and to deal with the life-threatening infections. Next comes fluoroquinolones. In fluoroquinolones, ciprofloxacin and levofloxacin are active against the Pseudomonas aeruginosa. Fluoroquinolones have something unique. I mean, fluoroquinolones are the only oral available antibiotic which are active against Pseudomonas aeruginosa. These are only orally available drugs which can be used to treat the Pseudomonas aeruginosa infection. Next is Monobat. Okay, and the last one is polymyxin B. This drug is rarely used. Reason is there are drugs better than this drug available in the market, and there are some adverse effects associated with this drug which is not present with other drugs, but it is still used. But it is still used in a very disparate situation where the Pseudomonas aeruginosa infection is overwhelming. So it is still in use, even though it has some disadvantages. Well, at the end of this section, I try to summarize the management options of Pseudomonas infection in this way. The treatment of choice of Pseudomonas infection is anti-pseudomonal penicillin plus aminoglycosides, and the anti-pseudomonal penicillin would include the piperacillin plus tazobactam, and the aminoglycoside would include the tobramycin, gentamicin, and amikacin. When these are combined together, they can be used to treat the Pseudomonas infections. And we can use the colistin for highly resistant citrates. And for UTI, fluoroquinolones can be used. They are available in oral form. Ciprofloxacin and levofloxacin can be used to treat UTI caused by Pseudomonas. Okay, there are some new experiences of treatment for Pseudomonas. For Pseudomonas in cystic fibrosis patient, inhaled antibiotics have been used in cystic fibrosis patient. Aerosolized tobramycin has been used, and there are evidences, there are clinical experiences which shows that it really improves the clinical situation. There are clinical improvement evidences. And now a final touch with our whole discussion with the description of vaccine. Vaccine preparation has been developed and has been proved immunogenic. The primary candidate for such vaccine preparations are burn patient, cystic fibrosis patient, patient with immunosuppression. But all these preparations are still experimental, and at this present time, no vaccine is commercially available. But we are hopeful that such vaccine will be available in near future. With this hope, we conclude our topic of Pseudomonas aeruginosa. Take care of yourself and your patients and protect your patient from Pseudomonas aeruginosa. I hope your precious time spending on this topic will be fruitful. Thank you for being with me throughout this discussion. Thank you very much.